Morning, good evening, good afternoon. Hey G9. Okay, I think this form of live video of my screen with my voice will be better than sending you quizzes or other notes. So let's start our first lesson in this medium. Okay, I hope that you are prepared. You have your physics notebooks. You have a pen, pencil, ruler, eventually calculator. If not, please stop this movie for a few minutes, organize it, and start. Okay, so topic of today's lesson is a magnetic field. Okay, you watched the movie about magnetic field created by the Earth. I hope that you know importance of magnetic field created by the Earth, but let's start from the beginning. Okay, so right point number one, what is a magnetic field? So magnetic field is a region where magnetic force acts. The idea is exactly the same and is in the case of gravitational field. I hope that you remember that gravitational field is also a region where gravitational force acts. Okay, so here we have something like theory of field. Field is a field. The same definition, but in the case of magnetic you have to refer to magnetic force. In the case of gravitational field you have to refer to the gravitational force. Okay, so right point number two, that magnetic field can be represented by field lines. Okay, it's a very good idea because what is a magnetic field line? Let me present a simple example on new slide. Okay, let's imagine that you have a typical bar magnet. Okay, bar magnet has two poles. Yeah, N pole and S pole. Okay. So let's imagine that N pole is here and S pole is here. And magnetic field lines created by magnet start at N pole and goes to S pole. Okay, let me draw a few. Let's say 2 here and 2 here. Okay, direction is also important. Field starts at N and goes to S. So direction is always from N to S. Okay, so what is a line? What is represented by magnetic field lines? Let's imagine zoom of this part. So I'm going to create a kind of circle here, and this circle presents very small part, let's say this one. Okay, this is something like a zoom. Is it clear? Okay, so this part is presented here. What is a direction of field line in this part? A field line goes from N through this small region to S. So in this region, a field line goes in such direction. And let's imagine that in this smaller region you have another very small bar magnet. It can be a magnetic needle, something which is very small, which is placed in this region. What will happen if with this magnet? This magnet will be aligned along this field line. So this part of the magnet will go in this side and this part of the magnet will go this side, that finally magnet will be aligned along this field line. And what will be a pole at this end? This end pole will be N, at this end pole will be S. Why? Remember, magnetic field line always starts at N pole and goes to S. So N must be here because the direction is in such direction. Okay, let's do exactly the same example with different position, let's say here. Okay, let's zoom it. Yeah. Okay, and again, in this very small region here, magnetic field line, the blue one, goes from left to right. Remember, from left to right, from N to S. So if you will place a very small magnet in this place, this small magnet will be aligned along field line in such way that north pole of this magnet will be to the right and south pole will be to the left. Why? Because again, field goes from S to N. Okay? So what is represented by magnetic field lines? Magnetic field line, single magnetic field line shows us the direction of orientation of small magnets placed in this region. Okay? So again, magnetic field line shows us direction of orientation of small magnets, small bar magnets placed at this region. Okay? So write point number 3. Let me change the slide. If you didn't finish, I'm going to continue my lesson. If you didn't finish, please stop the video for a moment, and then if you will be ready, if you will copy it, then you can move it forward. Okay? So point number 3. Magnetic field lines around, and now in bullet points I'm going to present what is the shape of magnetic field lines around known objects. So let's start with a bar magnet. Okay, we know this, it was presented on previous slide, so as short revision, if you have a bar magnet with 2 poles and an S, then always magnetic field starts at N and goes to S. Starts at N, goes to S. Starts at N, goes to S. Is it clear? Starts at N, goes to S, starts at N, goes to S, and starts at N, goes to S. Yeah, from N to S. Okay? Please copy this. And again, I'm going to continue. If you didn't finish, please stop the video and turn it when you will be ready. Okay, next is magnetic field around 2 bar magnets, or what will happen if bar magnet will be broken. Okay, so I'm going to write 2 bar magnets. Here we have 2 situations. So let's look. Let's imagine that you have 2 bar magnets which are faced by different poles. So N is near S of the second magnet. So what happens? Magnetic field starts at N and goes to the closest S. Okay, so in this region we have magnetic field lines directed from right side to the left side. But what around we have something like this, from N to S, from N to S. Okay, this is why 2 magnets which are faced by different poles attract. Okay, N attract S, S attracts N, which means that there is attraction between these 2 magnets. Okay, but magnets can be faced by the same poles. So let's imagine a situation when you have magnets, 1 and second magnet, which are orientated in such way. And again, the same rule. Magnetic field line starts at N and goes to S. Starts at N and goes to S. What happens here between 2 magnets? Lines are closer and closer but cannot touch one of another. So we have something like this. Yep. Oh, from N to S, from N to S, from N to S, from N to S. So naturally, let's look on this region. What happens? If magnets are closer, then lines are closer but repel one to another. Okay, what does it mean? If you have two magnets faced by the same pole, there is a natural repulsion between these two magnets, which is normal. Is it clear? Okay. Point is magnetic field lines around. And now bullet point number 3. I'm going to change a slide. Please copy this. Stop video, copy this when you will be ready. Turn it back. Because next point is magnetic field lines around Earth. Something you are experienced in. Yeah? Okay, so let's look. This is our Earth. I'm going to create two poles, North Pole and South Pole. These are geographical poles. You know from geography what the pole is, yes? Oh, the axis of rotation of the Earth crosses these two poles. Geographical. Okay. And now, can you imagine that inside the Earth we have something like a bar magnet? Of course, this is not true. Bar magnet doesn't exist inside the Earth, but Earth's magnetic field behaves as one created by a huge bar magnet. I hope I can move it a little tilt. I hope. Yes, yes. Yeah. Okay. So, what is important? Important is that magnetic North Pole is not located at the same place as geographical North Pole. Moreover, magnetic North Pole is located close to the geographical South Pole, and vice versa. Magnetic South is created very, very close to the geographical North. And of course, field starts at N and goes to S. Starts at N, goes to S. Starts at N, goes to S. Magnetic field goes away from the Earth's core. Magnetic field surrounds all Earth, which means that we can perceive it at the surface of the Earth. Probably no device called compass. It has a needle, magnetic needle, which when it's placed in the Earth's magnetic field is aligned along these lines, magnetic field lines. Okay? So we were talking about magnetic field. As a conclusion, you have to know that the magnetic field is something like a region in which, when magnet is placed, it perceives something which is called a magnetic force. Okay? Magnetic field can be represented by lines, magnetic field lines. And what does it mean? If a small bar magnet or a needle is placed in the region of magnetic field, then it's aligned along these lines. Okay? We're also talking about the magnetic field produced by bar magnet, by two bar magnets, phase of different poles or the same poles, and by the Earth. I hope that you remember what is the source of Earth's magnetic field. You are watching a movie. If you don't remember, please watch it again. The movie is Magnetic Storm. Yeah, the series is TV Universe, and the title of episode is Magnetic Storm. Okay, so you must know this movie. Okay, and the last point, point number 4. Strength of magnetic field. Okay, strength of magnetic field has a symbol of B. Okay, you don't need to know details how to calculate strength of magnetic field, but you must know that strength of magnetic field is expressed, the unit is Tesla. And symbol is 1T. So again, strength of magnetic field is represented by capital letter B, the same as strength of gravitational field, yeah, small letter G, or strength of electric field, capital letter E. And the unit is Tesla. And 1 Tesla is quite huge magnetic field. Okay, 1 Tesla is field produced by huge magnet of size of your chair or something like that. Okay, thank you for your attention. Please make notes. You have to have this in your notebook, okay? And during our next meeting, we will continue. I will be talking about magnetic force with more details. There will be equation, a kind of rule. Today was a theoretical lesson. Okay, so see you next time. Bye.